Okay, so now we know what hexadecimal is. Let's now convert our base 16 hex value to a denary value. So in order to convert a base 16 hex value to a base 10 denary value, we need to be able to answer this question here. So if we are at denary 16, what is the hex value? Another way to put it is, when you've run out of single digits for a hex value, what comes next? So before we do the hex to denary conversion, let's recap where we are with our binary conversion. So we've used this table many times to convert a binary number to a denary number, and we know, for example, that if we have a binary number 101, that is equivalent to the denary 5, because we are using this column but not this column, and we are using this column. So if we take a slight re-step on that, so the first value, if we're counting up from 0, is 0. Okay, so 0 is 0. And then we go to a 1, so a 1 is equivalent to denary 1. So we can't go to, we're talking about binary numbers here, so we have to go to a new column. Okay, so that binary number 10 is equivalent to denary 2. Okay, so that is equivalent to denary 3, and now we can't do that, can we? Because we can only deal with 1s and 0s. So we're having to go to a new column after we fill up with 1s. Okay, and it's exactly the same if we were looking at denary. If we get to 9, to count further up we need to go to 2 columns, and if we get to 99 in denary, then to count further we need to go to another column. And it is exactly the same in hexadecimal. So the hex to denary conversion table works in exactly the same way that the binary to denary conversion table does. So this binary conversion table goes up to the power of 2. So 2 times 2 is 4, 2 times 2 times 2 is 8, 2 times 2 times 2 times 2 is 16, and so on, because it is base 2. Now hex is not base 2, it is base 16, but the conversion table works in the same way. So we go 1, 16, and then it is 16 times 16, which is 256, and 16 times 16 times 16 is, yes, you guessed it, 4096. So this is me finally getting to the point now. So the original question was that if we get to F, which is the highest digit we can have without going into 2 columns, what happens next? And the eagle-eyed among you will have worked out that we do this. So remember, although this looks like it could look like a binary number, or it could look like a denary number, but the computer knows it is a hexadecimal number. So when we are 2 columns like this, we know that this is equivalent to a denary value of 16. Because we've got this second column once and nothing else. So what would the denary value 17 look like? It would look like that, okay, because it means we've got to 16 once and we've got to a 1 in this column. So 16 plus 1 is 17. So this hexadecimal number 11 is equivalent to the denary value 17. So let's do some more. So what do you think this value would be, so this is a hex value, what do you think that is as a denary value? Well, it means we've got to this column twice. So we do 16, which is the value of the column, times 2, which is obviously 32. Excuse the handwriting. And we haven't got any values in here. So 32 plus nothing is indeed 32. So hex 20 is equivalent to denary 32. So what about this hex number? It's easy to get confused, remember. This is not a decimal number, it's not a denary number, it is a hexadecimal number. The computer knows that, even if it looks the same. So it means that we've got to 16 twice. So that's 32, and we've got a 5 here, so 1 times 5 is 5. So 32 plus 5 is 37, which gives us our denary value for the hex value 25. Okay, so strangely I find it mentally just a bit less confusing once we start using letters. We know that the letters start at denary 10, so, and it's just a mental reminder that I'm not dealing with denary values, I'm dealing with a hex value. So we've got this column, it's 16, and we know that the value for A is 10. Remember, 10 is A, so 16 times 10 is 160, and we've got nothing in this column here, so nothing to add. So therefore A0 as a hex number is equivalent to the denary value 160. Okay, so what about this hexadecimal value? So what is AB as a denary value? Well, we know that A is equivalent to 10, so we take the column heading, so 16 times A, which is 10. Okay, so that's 160 plus, well, we know, if we know that A is 10, we know that B must be 11. So we take the column heading and we multiply it by the value, so B is 11. So 1 times 11 is 11, so 160 plus 11 is 171, which gives us our denary value for hexadecimal AB. So it's unlikely in an exam test, end of topic test or GCSE exam situation, you won't have a calculator. So it's probably not going to ask you something ridiculous like, you know, what that is in as a denary value, because then you'd have to do, well, it's going to be the column heading times the F value, denary value for F, so that would be times 15, and then you've got to do 10 times A, sorry, 256 times A, which is 2,560. So you're not going to get anything that hard, okay, but you are likely to get questions a bit like this. So this is probably about as hard as you are likely to get, so let's work it out. So we know that A is equivalent to denary 10, so we take the column heading, which is 2056, and multiply it by 10, so that gives us 2,560, and then we've got the column heading, so 16 times 1 is going to be 16, and C. So what is C? Well, remember, we know that 10 is A. Lock that into your brain. So if A is 10, then we know that C must be 12. So we take the column heading and multiply it by C. So 1 times 12 is of course 12. So all we need to do now is add these three together. So 2560 plus 16 is 2576 plus 12 gives us 2588. So our answer in Denary, equivalent to that hexadecimal number, is 2588. So it's not hard, it's just a matter of getting used to the routine so that you can answer these questions quickly in a test situation. So this one would be 1 times 16 plus 1 times 5. This one would be 2 times 16 plus 1 times 10. Okay, this one here would be 16 times 10, so that would be 160 plus 1 times 3, okay, and so on and so forth. So I would recommend you having practice with these so that you are really familiar, and just be always aware in the question what they're trying to get you to convert from and what they're trying to get you to convert into, because the next thing is we are in this topic, we're not just converting from hex to denary, we're converting from denary to hex, and from hex to binary, and from binary to hex. That's what's next.